The world feels solid, right? You push on a table and it pushes back. You walk across the floor and it holds you up. It all seems very real, very tangible. But then someone tells you a secret: almost everything around you, everything inside you, is actually empty space. Most of what we call matter, like the atoms that make up your hand or the wood of that table, is just tiny, tiny nuclei with even tinier electrons whizzing around them. And between those electrons and the nucleus, there's mostly nothing, just space. It's a weird thought. Like, if you blew up an atom to the size of a football stadium, the nucleus would be like a tiny pea in the middle. The electrons would be like dust motes floating around the edges, and the rest, just air, just empty. But this emptiness, this vast amount of space within and between atoms, is super important. It's why things are the size they are. It's why they feel solid. It's how light passes through stuff. It's how chemistry happens. But what if all that changed? What if that empty space, all of it, just disappeared? Not slowly, not gradually, just poof, gone. Imagine it, all that emptiness suddenly not empty anymore. It just vanishes. It's a huge thought. It changes everything. And I mean everything. First off, think about us, people. You, me, everyone. We are made of atoms, billions and billions of them. And each of those atoms has this big, mostly empty space. So if that space went away, what happens to us? We would just cease to be in any way we understand. Your body isn't solid. It's a collection of atoms held together by forces, and those forces work because of the space. The electrons in your hand push against the electrons on the table. That's why you can't put your hand through it. And it's not a true physical barrier in the way you might think. It's more like two magnets pushing against each other, even though they aren't touching. They have a field around them. That's kind of how atoms work with their electron clouds. So, if that space vanished, if the electrons were suddenly crushed into the nucleus, everything would change. Your entire body would collapse. Not shrink, not compress, but actually collapse down to an unbelievably tiny speck. A speck smaller than anything you could imagine. All the nuclei of all your atoms suddenly right next to each other. No space between them, no electrons forming clouds, just this super dense clump of protons and neutrons. It wouldn't be painful. There would be no time for pain, no brain to register it. Your brain, your nerves, your cells, your bones, they all depend on atoms having that space, on electrons being able to form bonds and interact. Without it, the very structure that makes you you would simply cease to exist. It would be instantaneous. One moment you're there, made of mostly empty space. The next you're not. You're just a super dense dust motet. And it's not just us. It's everything. Think about your house. The walls, the roof, the furniture, all made of atoms. And all those atoms are mostly empty space. So your house would also vanish into a tiny, tiny, impossibly dense nugget of matter. The concrete, the wood, the glass, the metal, all of it shrunk beyond recognition. The air around you, air is gas. Gas atoms are usually far apart with lots of space between them. If that space disappeared, the air would just collapse. There would be no atmosphere anymore. No oxygen to breathe, even if you still had a body to breathe with. The very concept of air, or gas, would be meaningless. Water, too. Water molecules, H2O, are built with hydrogen and oxygen atoms. These atoms bond in a specific way, and that bonding relies on electrons and their spatial arrangement. If the empty space within and between these atoms disappeared, water would not exist as water. It would just be a tiny, incredibly dense lump of hydrogen and oxygen nuclei. No oceans, no rivers, no clouds. So, the world we know, the physical world, would be utterly transformed. Let's think about density. This is where it gets really mind-bending. Right now, a sugar cube is pretty light. It's mostly carbon, hydrogen, and oxygen atoms. If all the empty space in that sugar cube disappeared, if its atoms collapsed down to just their nuclei, that sugar cube would become impossibly heavy. We're talking about something weighing billions of tons, all squeezed into the size of a tiny pinprick. This kind of super dense matter actually exists in the universe. We call it neutron star matter. When really massive stars die, they explode and their cores collapse under their own immense gravity. The gravity is so strong that it crushes protons and electrons together, forming neutrons. All the empty space is basically squeezed out. A spoonful of neutron star matter would weigh billions of tons. That's what everything would become if the empty space disappeared. Everything. So, the Earth itself. Our big blue planet. It's a massive ball of rock and metal. But like everything else, it's mostly empty space. If all that empty space vanished, the Earth would shrink dramatically. Instead of a planet thousands of miles across, it would become a tiny sphere, maybe only a few 100 feet wide, or even less. But it would still have all its mass. It would be incredibly, unbelievably dense. And what about gravity? Gravity depends on mass. The more mass something has, the more gravity it has. And the closer you are to that mass, the stronger the pull. If the Earth shrank to a tiny ball but kept all its mass, its gravity would become immense. Catastrophic. Imagine standing on the surface of this shrunken Earth. You would be instantly, brutally crushed by its incredible gravitational pull. Nothing could escape it. Not even light, possibly. It might become like a tiny black hole, or something very close to it. The moon would also shrink. The sun would shrink. Every planet in our solar system would become a tiny, super dense object. The sun is a star. It shines because of nuclear fusion. That's where hydrogen atoms are squeezed together to make helium, releasing enormous amounts of energy. This process needs high temperatures and pressures, but it also relies on atoms and their electrons. It needs a plasma, which is a gas where electrons are stripped from atoms. If all the empty space disappeared, if electrons were forced into nuclei, then nuclear fusion as we know it would stop. The sun would stop shining, it would collapse into a tiny, incredibly dense object. No more light, no more heat. Our solar system would become a collection of super dense, cold, dark specks, each with immense gravity. The planets would still orbit the sun, but it would be a very different kind of orbit around a very different kind of sun. And they would be much closer together because the entire solar system would have shrunk. The distances between objects are also mostly empty space, so the vast stretches between planets would shrink too. And it goes beyond our solar system, the whole universe. Every star, every galaxy, every nebula, every speck of dust, all of it is made of atoms, and all of it has this empty space. If that space just went away, the entire universe would shrink. What we see as vast, endless space full of distant galaxies would become a tiny, incredibly dense point. All the matter in the universe squeezed together. The implications for the fundamental forces of nature are even more profound. Right now, there are four main forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Electromagnetism is what holds atoms together, makes chemistry happen, and gives us light and electricity. It relies on charged particles, especially electrons. If electrons are crushed into nuclei, if there are no electron clouds, then electromagnetism as we understand it would cease to function. No more light reflecting off surfaces because there are no electron clouds to interact with photons. No more electricity, no more magnetism. The very basis of our sensory world, sight, touch, even hearing, would be gone. Sound needs a medium to travel, atoms with space between them to vibrate. No space, no sound. The strong nuclear force is what holds the nucleus of an atom together. It's incredibly powerful, but only over very short distances. If all atoms became just nuclei and they were all touching, then the strong nuclear force would become the dominant force everywhere. Everything would essentially become one giant, incredibly dense nucleus. This is a very unstable state for matter. The weak nuclear force is involved in radioactive decay. It might still exist, causing these super dense nuclei to transform, but in a way we can't really predict or understand. And gravity, as we talked about, would become extreme. It would warp space-time beyond recognition. Time itself might slow to an almost complete stop in these super dense regions. The universe would be a place of extreme gravity where nothing could move or escape. What would the universe look like? It wouldn't look like anything. There would be no light. Or if light still somehow existed, it would be so incredibly bent and warped by the extreme gravity of every single object that nothing could be seen. It would be a dark, silent, crushing void. But let's step back a bit and think about the exact moment this happens. It wouldn't be a gentle compression. It would be an instant, violent, cataclysmic event. Imagine the sheer amount of energy involved in compressing everything down to that level. When things are compressed, energy is released, usually as heat. Think about a gas being compressed, it gets hot. The universe is incredibly vast, and most of it is empty space. If all that empty space vanished, the compression would be beyond anything we could comprehend. There might be an incredible burst of energy, a flash of light so intense it would be indescribable, before the universe plunged into darkness. Or maybe it would just be an instant silent collapse. It's hard to say because our physics models break down at such extremes. The laws of physics, the very rules that govern our universe, are built on the idea of atoms having this structure, this space. Chemistry, biology, even astrophysics, they all depend on it. If that space disappeared, all those rules would be broken. They need to be rewritten entirely. We talk about the speed of light. Light travels through empty space. What if there's no empty space? Does light still have a place to go? Does it even exist? It's like asking what happens if you try to sail a boat on land. The premise itself fundamentally changes the possibilities. And thinking about it, the term empty space is a bit misleading in modern physics. Even what we call a vacuum isn't truly empty. It's teeming with virtual particles constantly popping in and out of existence. It's a field of quantum fluctuations. So if that empty space disappeared, it's not just the classical void that's gone. It's the very fabric of quantum reality that's been ripped away or changed. If this quantum vacuum itself disappeared, it would be an even deeper transformation. It's where energy fields reside, where particles emerge from. Without it, the fundamental nature of particles might change. Or they might not be able to exist at all. Consider the consequences for time itself. Time is linked to space. Our understanding of space-time as a unified fabric would be fundamentally altered by such a change. Extreme gravity warps time, making it slow down. If the entire universe became super dense and gravitationally extreme, time might effectively cease to pass, or pass at an infinitesimally slow rate. For any observers, if any could exist, the universe would effectively be frozen. And what about the possibility of life? Life as we know it is incredibly complex. It requires atoms to bond in specific ways, forming molecules, then proteins, then cells, then organisms. All of this depends on the electron clouds, on the space, on the electromagnetic force. If that went away, life would be impossible. There would be no chemistry, no biology. The very building blocks would be gone. This isn't just about things getting smaller. It's about a complete breakdown of structure. An atom isn't just a collection of particles. It's a system. A nucleus, electrons, and specific energy levels, the forces between them. That system creates the volume, the solidity, the identity of the atom. Without the space, the system is gone. The identity is gone. So when we say empty space disappears, we're really talking about the collapse of the entire atomic and subatomic structure that defines matter. It means electrons are forced into the nucleus. It means nuclei are forced into direct contact. It means the electromagnetic force is rendered moot, and the strong nuclear force becomes the dominant force everywhere. The universe would no longer be a vast, mostly empty expanse with pockets of matter. It would be a hyperdense, incredibly small, cold, dark, silent, and gravitationally extreme singularity of sorts. Not one big bang, but a universal crunch. A crunch that happens to every single atom everywhere all at once. And this crunch would not create something new in our understanding. It would destroy everything we know. There would be no light, no heat, no chemistry, no biology. There would just be this unimaginably dense, compact blob of nuclear matter. It's a scary thought how fragile our reality is, how much it depends on something as seemingly mundane as empty space. But it's also amazing to think about how complex and beautiful the universe is because of that very emptiness. It's the space that allows for interaction, for structure, for complexity. It's the space that allows light to travel, for stars to shine, for life to exist. Without that space, it's not just a different universe, it's effectively no universe, at least not one that could harbor any form of meaning, interaction, or existence as we understand it. It would be the ultimate end, a universe that folded in on itself, not into a black hole that exists within space, but one where space itself was eliminated. And the universe is always expanding, getting bigger, creating more space between galaxies. This hypothetical scenario is the exact opposite. It's a universe shrinking to nothing, not from a big crunch where gravity eventually pulls everything back together, but from an instant disappearance of the inherent space within matter itself. So, if someone asks you what would happen if the empty space between atoms disappeared, you can tell them it's not a small change. It's the end of everything. It's the universe saying, I'm done. No more stars, no more planets, no more people. Just an unbelievably dense, dark, silent speck. It's a thought experiment that shows us how fundamental that nothing really is. It shows us how everything we value and experience comes from atoms having that space, having that freedom to be more than just tightly packed nuclei. It's the reason anything can exist at all. It's the reason we're even here to think about it. Imagine standing on what used to be Earth. You couldn't. Not only because you wouldn't exist, but because if you could, the gravity would be so strong, it would pull you in faster than you could blink. Every single atom would be trying to pull everything else into itself. There would be no surface to stand on. No ground, just an incredible gravitational well, and the fabric of space-time itself would be so distorted that concepts like up or down or side to side might lose all meaning. The very geometry of the universe would be unrecognizable. It's not just a local effect confined to Earth or our solar system. This is a universe-wide event. Every single atom, everywhere. What about a ripple effect? If the space disappeared, would it travel like a wave, or would it be everywhere at once? The question implies an instantaneous change, a poof. If it was instantaneous, then the entire universe would undergo this transformation at the exact same moment. No time for any kind of ripple, just an immediate universal collapse. The energy within atoms, the binding energy, would be released. Think of the energy released from breaking apart a nucleus fission or forcing them together fusion. This event would be an extreme version of forcing everything together. The energy release would be unimaginable. It might be so vast that it creates a new kind of singularity, a point where all our physics breaks down entirely. It would be more energetic than any supernova, any gamma ray burst, but again, where would that energy go? If there's no space, no light, no heat, where does the energy manifest? It would be a cataclysmic, silent, dark release. A flash that no one would see, a roar that no one would hear. It's truly hard to grasp the scale. The difference between our current reality and this hypothetical one is like the difference between everything and nothing. And it's important to remember that the empty space isn't just empty, it's where the fields are. It's where the forces act. It's where particles exert influence over each other. It's not a void that can simply be removed without consequence. It's an active, dynamic part of reality. The thought experiment makes you appreciate the delicate balance of everything, how fundamental those little gaps are, how important the electron clouds are. They're not just some fluffy, insignificant bits. They are the reason things have volume. They are the reason matter interacts. They are the reason you can feel the warmth of the sun, or the chill of the wind, or the softness of a blanket. All of it comes down to those empty spaces. So, if that space disappeared, it means no more interactions. No more pushing, no more pulling, just a single, unified, ultra-dense block of nuclear matter. It wouldn't be a universe in any sense we would recognize. It would just be. Bye there. A monument to what once was, but now compressed beyond all recognition or understanding. And if somehow, by some impossible twist, observers could exist in such a state, their perception of time and space would be so warped that they might experience everything as an eternal frozen moment. No change, no movement, no light, no sound, just an ultimate, unimaginable stillness, where all of reality is crushed into a single, indescribable point. It's a scenario that pushes the boundaries of imagination and physics. It highlights that the universe isn't just a collection of particles. It's a collection of particles and the space between them, and both are equally crucial for everything to work. You remove one, and the other loses all meaning. The universe ceases to be the universe. It becomes something else entirely, something alien and terrifying in its ultimate simplicity and density. It's a world where the idea of world itself is meaningless. This isn't about compression like squeezing a sponge. It's about fundamental dimensions and forces changing. It's about the very concept of size becoming irrelevant because the mechanism that gives matter its size, the electron cloud, is gone. It's about the very concept of interaction becoming irrelevant because the space for those interactions is gone. So, what if the empty space between atoms disappeared? It means the game is over. The universe would just be a tiny, super dense blob, silent and dark. Nothing would move. Nothing would change. There would be no what if anymore, just the end. And that's why when we look around at the vastness of space, at the intricate dance of atoms in our own bodies, at the way everything is, we should be amazed. Amazed that there's so much nothing that allows for so much something. It's a beautiful, delicate balance, this universe we live in. And it all depends on those tiny, invisible spaces. It's what makes everything work. It's what makes everything be.